In this video, I'm going to formally prove a fact about triangles that you learned back in middle school, which is that the sum of the three angles, if you measure those three angles, the sum of those three measurements is going to equal 180 degrees. All right, so this will be handy because that's a great piece of information to have in our toolkit. It's great for you to see another proof being put together. And this is also going to be useful because I'm going to unveil a couple of extra reasons that you're going to see us be able to use, which is especially handy when we deal with numbers sometimes. So let's go to the document camera. All right, so here we have a triangle, and this could be any triangle at all. And what I did is I drew this dashed line. So this is an auxiliary line, just like we had an auxiliary line in the proof about the isosceles triangles, because we know that given this side, we can construct, we can even do this using a compass and straight edge, we can construct a line that's parallel to this line that goes through B. So we just move that up, and so that will be line DE. So we're given that line DE is parallel to line AC, and you see that that angle split us into three angles here. So I named them angle 1, angle 2, and angle 3. So what I want to prove is that the measure of angle A, remember that if we put an M before the angle, we're not talking about angle A as a geometric object, we're talking about the measurement of it as a number. So, you know, this might be 45 degrees or 20 degrees or something like that. So the measurement of angle A plus the measure of angle 2 plus the measure of angle C is equal to 180 degrees. So in this arbitrary triangle, which we know nothing about, we're not given any special facts about this triangle, we want to prove that the sum of the three angles is equal to 180 degrees. All right, so let's set up our proof. First thing, the way we will probably always start off proofs is with our givens. So the line segment AC is parallel to line DE. And what was our reason for that? That is what we were given in this proof. All right, so because we've got these parallel lines, one thing that's really handy to look for is looking for corresponding angles or alternate interior angles. So do you see any in this diagram? Well, I see an alternate interior angle pair. So I'm going to take my yellow highlighter and I'm going to give this the mark of Zorro. All right, so based on that, what two angles do I know are congruent? Well, the angle at the top is what we called angle 1. And the angle down here at the bottom is angle A. So we know that angle 1 is congruent to angle A. And the reason for that is that they are alternate interior angles. All right. Do you see any other alternate interior pairs in this diagram? I'll give you a hint. Sometimes the mark of Zorro needs to be backwards in order for it to work out. And we do. So I'll take my pink highlighter and swish, swish, swish like this. So what are my alternate interior angles looking at the two parallel lines with BC as my transversal instead of AB? Well, the top angle is angle 3, and the bottom angle is angle C. And once again, and when you're writing this out, you can see, just like I'm doing here, you can abbreviate as long as it's clear what it is that you're saying. All right, so that's pretty cool. The next thing I want to do is I want to talk about a relationship between angles 1, 2, and 3. Because what do you notice about those three angles? Well, those three angles are part of this straight line. If we put them together, They're going to make a straight line. And how many degrees are in a straight line? So a straight line is half of the entire circle, or half of 360 degrees, so it's 180 degrees. So I can say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And my reason for this, we haven't seen this reason before, so this will be something you'll want to pay attention to. I am going to say that this is the additive property of angle measures. All right. So here's what I'm saying. I'm saying if I add up these three things, if I add up the measurements of these three angles, I'm going to get the measurement of what those three angles add up to. These three angles add up to a straight line. A straight line has 180 degrees. So these three measurements add up to 180 degrees. That's the additive property of angle measures. You'll also see when you do proofs the additive property of side lengths. So if I had, just as a separate proof, okay, so if I said that xy, remember when I draw xy with a bar, I'm talking about the line segment, but when I draw xy with nothing, I'm talking about the distance between these 2 points. So this is a number. So if I say xy plus yz is equal to xz, the sum of these two lengths has got to be equal to the sum of the entire length. That would be the additive property of length. Prop of length. Okay, so that's a new proof reason that we might be exposed to at some point in time. So I don't want to know about the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, though. What I want to talk about is the measure of angle A plus the measure of angle 2 plus the measure of angle C. Can you guess how I can get from here to here based on what I already have in the proof? Well, for instance, I know that angle 1 is congruent to angle A. And so therefore, the measure of angle 1, if I measured this angle, it would be the same answer as I got if I found the measure of this angle. That's what it means to be congruent. So what I'm going to do is I'm going to write this. I'm going to say the measure of angle A plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. All right, all I did was take out angle 1 and replace it with angle 2, which I can do because they're congruent to each other. And the formal reason I'm going to give for this is substitution. All right, so that's a nice word because it's letting me know exactly what I'm doing. I'm substituting angle 1 with angle A because I know that angle 1 and angle A are congruent to each other. So they've got the same measurement. So these are the same number. All right, and I need one more line of the proof to finish. So this is the measure of angle A plus the measure of angle 2 plus the measure of angle C is equal to 180 degrees. So see if you can tell the difference between line 5 and line 6 and what my reason for that would be. Well, once again, the only difference is that I substituted out measure of angle 3 and I substituted in the measure of angle C. And the reason I'm allowed to do that is because I showed here earlier in the proof that angle 3 is congruent to angle C, so they must have the same measurement. So once again, my reason here is substitution. All right, and so since the last line of the proof is what I wanted to prove, we're done. Okay, so what we did here is we proved that the sum of the three angles of any triangle is equal to 180 degrees. So that's pretty cool. And the other thing that we saw in this video is we've seen an example of the additive property, where we get to another way you'll sometimes hear people describing the additive property is they say that the whole is equal to the sum of its parts. All right, so the whole straight line is equal to the sum of the three angles that made it up. So that's what allowed us to say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of an entire straight angle, which is 180 degrees. In IXL, you're going to see that called the additive property of angle measures, and you'll also see examples where we're going to talk about the additive property of lengths when you do proofs. All right, and the other thing we learned about is we saw an example of the substitution reason for proofs. So if we know two things are congruent to each other, we can replace one with the other in any statement and it'll still be true.